In the last few sections, we got a better idea of how Node works, and now understand that Node internally uses the JavaScript V8 engine and the C++ library libuv to work correctly. In this video and the next few, we're going to start to dive into something called the event loop. The event loop is used by Node to handle asynchronous code that you and I write inside of our applications. Before going straight into the event loop, however, we're going to do a very brief detour and discuss something called threads. Once we understand what a thread is, we'll then go back over to the Node event loop. So in this video, let's get to it. We're going to start to discuss threads and what they are. All right, here we go. Whenever you and I run programs on our computer, we start up something called a process. A process is an instance of a computer program that is being executed. Within a single process, we can have multiple things called threads. You can picture a thread right here as being like a little to-do list that has some number of instructions that need to be executed by the CPU of your computer. This thread is given to the CPU, and the CPU will attempt to run every instruction on it one by one, starting at the top and then going down. A single process can have multiple threads inside of it. And in fact, I can actually very easily prove that to you by opening up the activity monitor on my personal laptop. So here's my activity monitor. It lists out all the different processes that are being ran on my computer. If you look at the bottom right over here, and I know the text is really small, but you can see that I've got about 250 different processes running right now. And inside there are about 1,400 different threads. So every one of these threads belongs to one individual process. One of the most interesting and important areas of study around threads is understanding something called scheduling. Scheduling refers to your operating system's ability to decide which thread to process at any given instant in time. So remember, your computer has a limited amount of resources available to it, and your CPU can only process so many instructions per second. This starts to get really relevant when we have many active processes and threads on our computer. Each one of these threads right here might have some urgent responsibility assigned to it. Like over here, we might have a thread that is responsible for making sure that whenever the user moves their mouse, the cursor on the screen moves as well. Or we might have another thread whose job is to make sure that keyboard typing or keyboard input shows up inside of some text input whenever the user types. So your operating system's scheduler over here has to look at all these different threads that are asking to be processed and figure out how to do some amount of work on each of them while making sure that they don't have to wait too long to be processed. Now that last part is really important. We want to make sure that urgent threads don't have to wait too long to be executed. So for example, if the thread in charge of moving the mouse around the screen has to wait like 5 seconds before it gets processed, the cursor will not move during that time, and the user is going to think that their computer is broken, which is obviously not good at all. There are a couple of different strategies that are used to improve the rate at which these threads can be processed. We're going to focus on two in particular that are going to end up being very relevant for us in the Node.js world. So in order to more quickly process threads or process more at one given time, we can first add in additional CPU cores to our machine. So if we have more than one core inside of our CPU, then we can easily process multiple threads at the same time. One thing I want to mention here is that technically one core can process more than one thread at a time through a process called multi-threading, or you may have also heard it referred to as hyper-threading as well. But for right now, let's just say that more cores means more threads processed at once. The second thing we can do is more closely examine the work that is being done by each thread. So this is where things start to get really relevant for us in the JavaScript world. Let's imagine for a second that we have two threads here that are both competing for processing power. Thread number one has a set of instructions that want to read a file off the hard drive and then maybe count the number of characters inside of it. And then thread number two over here wants to multiply 3 by 3. The thing to keep in mind is that any time our computer tries to read data off of some type of medium, like a hard drive, we refer to that as input or output operations. and it always takes some non-zero amount of time. So during this I/O phase right here, your CPU is waiting on the hard drive to read some file and return its contents. And during that time, this thread number 1, has absolutely nothing else to do. It's just sitting there waiting for the hard drive to get some information. Your operating system scheduler has the ability to detect this downtime, or this kind of pause between instructions. And it can decide to put thread number 1 on pause and then execute thread number 2. And then as soon as thread number 2 is complete, it can go back over to thread number 1 and continue waiting on the hard drive to be read from the file to be read from the hard drive. Okay, so quick recap here. In this section, we spoke about some of the basics of threads. Threads are units of instruction that are waiting to be executed by the CPU. Deciding which order to execute these threads in is referred to as scheduling. Scheduling is controlled by your operating system. Two ways of improving the rate at which we process threads is to either add more CPU cores to our machine or to allow our OS scheduler to detect big pauses in processing time due to expensive input and output operations. So now that we understand a little bit more about threads, let's continue into the next section, and we're going to start to apply this knowledge to the node event loop. So quick break, and I'll see you in just a minute.